Hello everyone, how you guys doing? This is Malavya and welcome to yet another episode of factsow. So in today's episode, I'll be talking about the ancient Indian astronomer and mathematician Bhaskaracharya. This video is gonna be in few parts where I'll be talking about the Bhaskaracharya's biography and his several achievements. But before we begin, make sure you subscribe to the channel and press the bell icon. Bhaskaracharya's biography. Bhaskara or Bhaskaracharya, commonly called as Bhaskara I to avoid the confusion with the 12th century mathematician Bhaskara II. Bhaskara I was a 7th century mathematician born around 600 CE. There is very little that we know about Bhaskara's life. There are some references of places in India that is mentioned in his writings. For example, he mentions Vallabhi, that is today's Vala, and another one is Sivarajpur. Vallabhi was the capital of Matrika dynasty in the 7th century. Both of these places were situated in Saurashtra, which today is the Gujarat state of India. His writings also mentions about the Bharuch of Gujarat and Thanesar of Punjab. A reasonable guess would be that Bhaskara was born in Saurashtra and later moved to Asmaka, which was a Mahajanpad located in and around river Godavari. His astronomical education was given by his father. Bhaskar is considered the most important scholar of Aryabhat's astronomical school. He and Brahmagupta are two of the most renowned Indian mathematicians who made considerable contributions to the study of fraction. Bhaskara I died around 680 CE. Next, representation of numbers. Bhaskara's probably most important mathematical contribution concerns the representation of numbers in a positional system. The first positional representations had been known to Indian astronomers approximately 500 years prior to Bhaskar. However, these numbers were not written in figures but in words or allegories and were organized in verses. For instance, the number 1 was given as moon. Since it exists only once, the number 2 was represented by wings, twins or eyes, since they always occur in pairs. The number 5 was given by the 5 senses, etc. Bhaskara's system was truly positional. He often explains the number given in this system using the formula Anke Repi, that is, in figures this reads. He used this by repeating numbers written with the first 9 Brahmi numerals using a small circle for the 0. Contrary to his word system, however, the figures are written in descending values from left to right exactly as we do it today. This tells us that at least since 629 CE, the decimal system was definitely known to the Indian scientists. Next, the Bhaskara I sine approximation formula. Bhaskara's approximation to the sine function was 99% accurate. He did this by using a function that is simply a ratio of equations. He mentioned this formula in the form of verses in his book Mahabhaskarya. To be accurate, this was mentioned in the verse number 17 to 19 of chapter 7 of the book Mahabhaskarya. Next, Mahabhaskarya, the great book of Bhaskar. The Mahabhaskarya is a work on Indian mathematical astronomy consisting of 8 chapters that deals with mathematical astronomy. It covers topics like the longitudes of the planets, association of the planets with each other, conjunctions among the planet and the stars, the lunar crescent, solar and lunar eclipse, and rising and setting of the planets along with the sine approximation formula. Some part of this book were later translated into Arabic. Next, Laghu Bhaskarya, the small book of Bhaskara. Laghu Bhaskarya is another book by Bhaskara. The topics covered in this book are mean and true longitudes of the planet, direction, place and time from shadow, lunar and solar eclipse, visibility, phases and rising and setting of the moon, visibility and conjunctions of the planet and conjunctions of the planet and stars. Next, the Aryabhatiya Bhashya. Bhaskara I made commentary on only known surviving book of 5th century mathematician Aryabhat, and he named it as Aryabhatiya Bhashya. Bhaskara I's comments revolve around the 33 verses in Aryabhatiya, which is about mathematical astronomy. He also expounds on the problems of indeterminate equations and trigonometric formulas. While discussing Aryabhatiya, he discussed cyclic quadrilaterals. He was the first mathematician to discuss quadrilaterals whose 4 sides are not equal with none of the opposite sides parallel. Bhaskara I explains in detail the Aryabhat's method of solving linear equations with illustrative examples. Next, Bhaskara's influence and future comments. He firmly believed that if p is a prime number, then 1 plus p minus 1 factorial is divisible by p. It was proved later by Al-Haitham, which was also mentioned by Fibonacci and is now known as Wilson's theorem. Bhaskara I had also stated theorems about the solutions of today's so-called Pell equations. For example, he posed the problem as, tell me, O mathematician, what is that square which multiplied by 8 becomes together with unity I square? Which in modern notation he asked for the solutions of the Pell equation. It has the simple solution x equals to 1, y equals to 3, or shortly x comma y equals to 1 comma 3, from which further solutions can be constructed. Example, x comma y equals to 6 comma 17. Bhaskara 1 also stressed on the need for providing the mathematical rules. Bhaskara 1 played important role in lasting influence of Aryabhat's work. On 7 June 1979, ISRO, the Indian Space Research Organization, launched Bhaskara 1 honoring the mathematician. His sign approximation formula is still in use because of its accurate answers. So this was from me. Hope you like the content. Hit the like button, subscribe to the channel, press the bell icon. You can follow me on Instagram. You can also follow the official Insta page of factsow, where you can get a new fact post every day. Here Malavya signing off.